Right, morning folks. When I was asked to come speak at the CTO Summit, they said, we're looking for some content that's relevant to CTOs and VPs of engineering, and I was like, I'm none of those things. And then it occurred to me, wait, I've got all the stories. So I'm an independent consultant, and I specialize in software architecture, and I get invited to organizations by CTOs and VPs of engineering and development managers, so I thought, perfect. And these organizations typically invite me in to help them solve a couple of problems, so I'm going to talk about those, and I'm also going to talk about a couple of the other challenges that I see these organizations face. So some blurb about me, not very interesting, let's dive into. So the first category of problems that organizations pull me in to talk about is really upfront design. And the people who invite me in typically say things like this in their emails. So we have a bunch of developers and they don't think about the bigger picture, or our developers are not thinking sufficiently about the future. Any of these starting to ring a few bells? Our developers are accumulating lots of technical debt, which is slowing us down, or they're not thinking through their decisions and the trade-offs. So these are the types of things that organizations will typically say to me. Now, why is this happening? Well, of course, back in 2001, the whole Agile thing kicked off, and the Agile Manifesto was created, and lots of organizations threw away upfront design, especially big upfront design. And you might have heard people in your teams and organizations say stuff like this: we don't need architects, or everybody should be an architect. And that's fine, but there's a great quote I like to use here by Dave Thomas. Big design up front is dumb, doing no design up front is even dumber. I literally use this slide in every single talk now, because it just epitomizes what I've seen over the past 17 or 18 years. Now, I want to caveat a lot of what I'm about to talk about. I'm really referring to technical design, not product design. So all of the wireframing, UI, UX, A/B testing, super important, definitely do that. That's not what I'm here talking about. I'm going to talk about the technical stuff. So choosing technologies, choosing structures, modularities, and the underlying architecture and frameworks of the stuff that we are ultimately building. You folks seen this before? Yeah, a million times likely. So this is the Henrik Nieberg cartoon. It's typically associated with Spotify, and it's about throwing stuff out there and getting some feedback, experimentation. And this is a great way to summarize how we might want to follow that process. So rather than giving someone a car in a number of years, we give them something that basically fulfills the task, and we get feedback as quick as we can. Now, we've seen this a lot of times, but the thing people don't talk about is, well, you don't just build the final thing. You don't just go build the car. Every step, every iteration is a complete re-engineering effort. And that's what people miss. And what I've noticed is organizations are taking a very superficial approach to their thinking and their upfront design activities. So one of the things I do is I work with organizations around the world, and I run architecture charters where I give the attendees some requirements, and I say, you have 1.5 hours, go and do some design. And what tends to happen is they do the design very quickly, because we're agile, of course, and they come up with diagrams that look like this. They're very high level, they're very superficial, and they've not really got into the complexities of the problem space yet. There's a great book about architecture by George Fairbanks. And in this book, he says, a good architecture rarely happens through architecture in different design. In other words, this is just jumping on a solution because that's what we've always done, or trend and hype and fashion. And do you know what falls into this category? Microservices. I see this a lot. I see still a lot of organizations jumping blindly on microservices because they think it's going to fix some problem they have. We have a 15-year-old legacy Java monolith, and it's too hard to change. It's too hard to deploy, and it's just buggy and broken. So we're going to rebuild it as a set of distributed microservices. 2 years goes past, guess what? They create a distributed version of what they had before because they use the same design thinking. They just stick synchronous HTTPS calls in between the things. And teams are not thinking about how to do stuff properly. They're just jumping on solutions. And I see this also with serverless now, of course. Well, that hits them. You got this S-curve of learning, and what I'm seeing lots of people doing is they're kind of getting stuck down here. Now, we don't want to do this. We don't want to spend lots and lots and lots of time thinking about everything, but there's some accelerated learning that we can get to actually quite quickly if we put our mind to it. And that's the thing I'm trying to get teams to do. I want them to do a little bit more thinking, but stop when they've done enough. How do we get into this situation? There's a book about this. It's a little bit hard to find. It's called 97 Strategies to Avoid Upfront Design. Notice the author, Agile. It works better when you say it in a German accent. Agile. I'm going to have to work on that, aren't I? Dad joke 101. I'll stick to my day job. So in this book is a bunch of reasons that people give me for not doing upfront design. Are we allowed to do upfront design? I actually have teams ask me this question, which is kind of tragic. We don't do upfront design because we do extreme programming. What? That makes no sense at all. We're Agile, so therefore we don't think we need to do upfront design. It's not expected in Agile. Hey, there's quite a lot, unfortunately. Where did this come from? Well, it turns out when you go and do some digging around the internet, and you go to Wikipedia, and I know Wikipedia is not the best place to get some information, but you'll see people saying stuff like this, there is no big design up front in Agile. We do little things and iterate. Martin Fowler, in his Blicky, Design is Dead. You can see here, certainly the most aggressive ex-peers are putting more and more energy into avoiding any upfront architectural design. And so people are reading this and thinking, oh, that's what we need to do as well. And one of the problems I see here is that because we as an industry are not talking so much about doing design anymore, people are making the assumption that design is no longer important. And that's one of the things we seem to fall foul of quite a lot. The stuff we're not saying is important, even if we're not saying it. And this happened to me. So last time I did a variation on this talk. Again, it was about 30 minutes. A guy came up to me at the end and said, that was great, except, and he literally ranted at me for 5 minutes about all the stuff I'd not covered. And he would not let me get a word in edgeways. And after he finished ranting, I said, all that stuff's in my book. And he just walked off. You'll hear people talk about evolutionary architecture as one of the things we should do these days when we're doing our modern, lean, agile things, our product deliveries. And all of this stuff is good, and there's some great stuff in this book, and there are some great techniques here, but it's hard. It's really hard, and nobody tells you how hard it is, because you have to get the ordering of your decisions right. Otherwise, you end up creating lots of technical debt very, very quickly. And the thing with evolutionary architecture is that even if you are creating an architecture to be evolvable, you're still making significant decisions, and you still need to make those significant decisions consciously. So, for example, people say, well, we want our architecture to be evolvable, so we're going to choose microservices. Well, guess what? Decision made. Now you're stuck with that. Or we are going to build a Java-based monolith based upon the ports and adapters architecture. Well, guess what? Now you're stuck with a Java-based monolith. So you are sometimes unconsciously making these significant decisions, and that's the thing to watch out for. Sometimes when I talk about this topic, people actually say, well, hang on a second, you mostly do consulting, so we're not going to listen to you. Are you actually a programmer here? So my background is in building software. So I actually find this quite offensive when somebody said this to me. And it turns out I have two jobs. So one job is doing the consulting training stuff, and I do have my own startup. It's called Structurizr, and it's a whole collection of tooling based upon the C4 model and drawing architecture diagrams and architecture documentation. And this thing I've built myself from scratch, and it's been running for about 5 years now, and yeah, guess what? I've had to evolve the architecture. I put an initial version in place, and it kind of was sufficient at the start, and I've had to change it. I've had to add things and take things away and modify things. So I know how this works from a real-world perspective as well. So the whole agility thing here, we're ultimately talking about teams that want to become more agile. Agility needs a toolbox of practices, but we seem to have stopped teaching a lot of that stuff, particularly when it comes to some of the design type things. So how do we fix this? What's my advice? A simple thing you can do and this doesn't take much time and effort, is to run architecture charters. You don't need me to do this. You go onto the internet, you do a search for architecture charter. There's a whole bunch out there. Neil Ford has a bunch. Ted Newman has a bunch. I have one on my website as well. You create a nice sort of safe space. You have groups of like 2, 3, 4 people. You give them some requirements. You say, go away for a couple of hours, do some design, draw some pictures. And then you review the outputs. So when I do my architecture charters, I'm typically doing this from a diagramming viewpoint. So I'm asking people to review the diagrams. But you can ask people to evaluate the architecture. Does it meet the requirements? Is it suitable for the future? Can we add these sorts of things in the future? Is it open for change and that sort of thing? And these exercises are very simple to run. They don't need any special equipment or anything, just some paper and whiteboards and sticky notes. So this is definitely something that you should think about doing. Why? When people are designing software, ultimately what they want to be doing is answering these 2 questions. So here's a bunch of stuff. Here's something we want to design or something we want to change. Do these visuals, do these pictures reflect what we think we're actually going to build or change? And are we confident it's going to work? And that's what we're trying to get out of these. These are basically the 2 key questions we're aiming for here. Something else you can do related to the architecture charters is to put some expectations on how much upfront design you expect your teams to be doing. This is a little bit harder to quantify, of course, because people often ask me, well, how much design should we do? And they're normally looking for like a number of days or something. I've heard people say this. I've heard some of the Agile luminaries say this. I'm good with maybe a day for a 1-year effort of development. Well, that's kind of context dependent. I mean, maybe that works, maybe it doesn't. So we need a slightly better answer, I think. I think how much upfront design should we do is the wrong question. I think a better question is potentially, when do we stop doing upfront design? And so for this reason, I think any upfront design you do is iterative and it's incremental. And you should stop when you understand the things that are fundamentally driving your design, your architecture. So these are your important functional requirements, whether they're stories, use cases, don't care. The quality attributes, performance, scaling, especially things like security, of course. The constraints of the world around you. We always forget about this stuff, but those are super important. So once you understand those things at a high level, you're good. If you understand the context and the scope of what you're building, you're in a good place. So if you can draw a simple diagram that says, this is the thing we're building, these are the various types of users, and these are the systems we interact with, you're in a good place. And lots of people can't do that. You are conscious and you understand the significant design decisions that your teams are making. Typically, these are things like choice of language, technologies, APIs, data storage paradigms, and basically modularity. So it's all of these major design type decisions. That's what we're really aiming for here. You have a way to share this information with other people on your teams and within your organization, and we'll get to that in a second. You're confident it's going to work, so you're confident that your design satisfies those architecture drivers, and you're comfortable with the risk profile. That's actually not something we talk about much. I often get teams say, well, we're doing an Agile thing, how do we deal with technical risks? And my answer is go and read the RUP book, Rational Unified Process, because we've done this before. You just front load some of the risky stuff to the early stages of your life cycle. You do some concrete experiments, you write some code, proof of concepts, tracers, there's a whole bunch of words for these things. So that's really my definition of when do you stop doing upfront design? And I definitely urge teams to make it collaborative. And this is not just a developer thing. This is a cross-functional thing with many people across your organizations. So something I see organizations do is they do collaborative design, and then they throw Stride on top to do security reviews. Or they get infrastructure people involved to make sure that everything's feasible. So you can include a much broader range of people than you might have been doing in the past. So that's kind of category one, the design stuff. That's one of the major reasons organizations tend to get me in. The second one, surprisingly, is documentation. And organizations will say, well, we have no documentation. Who here has no documentation? No, don't answer that question. I know it's all of you. Our developers don't understand the bigger picture. So I see this a lot, teams have their own little focus and silo, and they're not really looking outside those silos. Or this one, this is quite common. It takes new joiners up to 6 months to get productive. And this is just wasted time and money. How can we fast track and streamline that process? Or, because nothing's written down, developers are going over and over and over the same ground constantly. And in some cases, reinventing the wheel. So why did this stuff happen? Well, guess what? Back in 2001, the Agile thing kicked off. And in addition to throwing away big upfront design, lots of organizations also threw away documentation, diagram, and modeling. And that's super unfortunate because everything got coupled together and thrown away. It's the throwing the baby away with the bathwater thing. People say, well, we don't need documentation because the code tells us everything. Nope, doesn't. Doesn't tell you why. It doesn't tell you the factors that led to that thing being built, the design, the way it satisfies the quality attributes. There's a whole bunch of stuff missing here. And both existing and new team members can't get that information just from reading millions of lines of Java code. Something you'll hear organizations say these days is, well, we just use whiteboards. This is super common. And the problem with this is we've completely forgotten how to describe the stuff we are building. So when I run architecture katas, one of the outputs I ask is, can you draw a bunch of diagrams to describe and showcase your designs? And I get diagrams like this, or that, or this one, or that. It's Hong Kong, or Heathrow. Crazy stuff over here, UI upside down. This one represents everything your teams are building. You have systems that do business logic. Yay. Diagrams like this with no tech choices on. Diagrams that just don't make any sense. Adventure books. Go through the different paths, choose different stories. Stormtroopers. Now, none of these diagrams make any sense whatsoever, and I've got gigabytes and gigabytes of gigabytes of these photos at home like this. And we've totally forgotten how to describe and visualize and even talk about the stuff that we're building, which is just tragic. Now, people often say, well, hang on a second, these diagrams are fine as long as you're having a conversation. The value is in the conversation. No, it's not. Because most of the time, the teams are having completely the wrong conversations because they can't see what the things are trying to describe. Right? If you can't see the solutions, you can't have the conversations. You can't have the right conversations anyway. So how do we fix this problem? Well, we need to write some documentation. This goes down really well. We have no documentation. How should we fix it? Go write some documentation. Thank you, Simon. Right? How do we actually do this? So I have a concept in my books you can read about. It's called the software guidebook. And the analogy I use here is like a travel guidebook. So when you're jumping on an airplane somewhere new, you pick up a little travel guidebook. It's like 50 or 100 pages. You flick through it really, really quickly. When you land, you have a good basis to go do exploring. The same is true with these code bases and these systems. When your teams are growing and people are joining your teams, you give them a little piece of documentation they can fly through very quickly, and then they can jump into your million lines of code. And it's a process to speed up that whole thing. So I have a template there. It's called the software guidebook. There's another one. It's relatively popular in Germany and German-speaking countries, not much else at the moment. It's called Art42, also a good template. Architecture decision records are becoming much more popular these days. So we're capturing the reasoning and the rationale about why we're designing stuff. So why did we choose Java over C#? Why did we choose Lambdas over Azure functions? So we're recording this stuff so we're not revisiting the decisions over and over and over again. So there's some good stuff you can look up there. In terms of the description and the visualization stuff, we lack a good ubiquitous language to describe the architectures of our software. And that's one of the biggest problems I see teams having these days. And this also relates back to the design stuff, of course. If you can't visualize something, it's hard to see whether your design satisfies the requirements, for example. So I have this thing called the C4 model, which you can find on c4model.com. And it's a set of hierarchical diagrams that organizations use to describe their architecture. And the analogy I'm using here is basically maps. So it's diagrams as maps. It's diagrams at different levels of detail, different levels of abstraction. And these different levels of diagrams allow you to tell different stories to different audiences. So the high-level diagrams work great for everybody across an organization, technical and non-technical. As you drop down into more detail, you get diagrams that are useful for developers and architects and operations staff and infrastructure staff. And as you get deeper still, these are really just in the development domain. And it's a notation-independent approach. So you can use boxes and lines diagrams, which people seem to favor these days, or you can use UML. Doesn't matter, don't care. Once you have a look at these diagrams, and one of the things I advise people is don't do all the levels because that's crazy, of course. But once you have a decent set of diagrams and you're able to visualize the solutions that you want to build or change, you can now use these diagrams as a checklist for your design, as a visual checklist. And this is super, super powerful. So the first diagram I urge all groups to create is a system context diagram. And it basically says, this is the thing you are building or changing. Here are your different types of users, actors, roles, personas. And these are these sets of systems that you interact with, or they interact with you. So those are the sorts of questions that we're having to go and ask in order to draw this diagram. And the diagram's nice and simple. In this case, this group was designing this system here. They've identified a couple of users and a whole bunch of systems that they're integrating with. And we got some detail on here, and you can find more about this on the C4 model. And that's a great starting point, because now we can say, right, this is what we're building, and we can anchor ourselves. If we're happy with this, we can now move on. So now we drill down into level 2, and we get to what I call containers. And containers are really just the high-level technology building blocks. So it's the collection of microservices and data stores that come together to form your systems. It's your monolith applications, your databases, and all that sort of stuff. And again, what we're now looking to do is we're looking to ask questions like, what are the responsibilities of these building blocks? What sort of deployment units are we creating? And how do these things communicate at runtime? And again, we hopefully get some nice diagrams, and now we get to see some technical details. And this is great for not only the development team, but also architects and lots of other people in the organization, operations staff and infrastructure and so on. And the whole point of focusing on diagrams is that we should now ask actually useful questions for change. Whenever people are drawing diagrams, they're always asking stuff like this, like what do the colors mean, what the arrows mean, and it's just all garbage. This is just noise. We want to get rid of this. So the C4 stuff has a whole bunch of guidelines for avoiding these questions. The questions we really want to get to are things like this. So I can see you've got two applications here. How are they talking to each other across the network? Why have you got a bunch of lambdas when you could be using something a bit more coarse-grained instead? Why have you got two databases, not one? So now we can ask a lot more interesting questions and really challenge the designs. And this gets people, again, thinking about those significant decisions and whether they're correct and appropriate given the context, the budget, and so on. The diagrams also provide a way to get meaningful feedback. This is an unintended side effect, I do have to admit, but when I run my architecture cartas, people often ask me a question, and the question goes like this. We're trying to diagram a serverless or microservices architecture, but our diagram looks complicated. Help. And really, the question they're asking is, how do we make the diagram look nice? And I don't answer that. I say, well, in order to make the diagram look nice, you need to simplify your architecture. The requirements I give people are like super simple. And a lot of organizations now are using serverless and microservices approaches to solving this problem, and it's just ridiculous. And once they start drawing out like 20 boxes and links between them, like, oh, this is way complicated. And that's good, right? If you have a complicated diagram, you have a complicated architecture. Let's not lie about these things. So that's category 2. This is not what people call me in to talk about, but I see this happening in many organizations, and it's really this whole concept of, do we still need centralized architecture groups? And of course, this is more prevalent in the larger organizations. So are centralized architecture groups still useful in today's modern lean agile world where everybody should be architects and have complete autonomy? Well, I think the answer is ultimately yes. So I think teams can get a lot of benefit from having a slightly longer term view of the world, a slightly more holistic view of the world that a lot of teams don't necessarily have today. So I definitely think there's a role in most organizations for some sort of higher level group of architects who are looking across a bunch of development teams. The trick is, how do they do that? If you're doing the dictating thing, if you're barking orders at all of your team saying you must use this version of this technology and you must deploy your apps on this cloud platform, right, that might not work as well. So as a developer, I've been in this situation where I've been on a team and I've had central architects barking at me and they've not written code for 20 years. And that's very demotivating for me as a developer. So you do have to watch how you do this. A number of the organizations I work with, the better ones I think, they tend to take more of a kind of consulting and guiding type approach to their central architecture teams. So they're being proactive and they're trying to help out the teams as much as possible. Some of these groups are physical. So some of these are like a set of architects and their sole day-to-day job is just to do central architecture work. They're not attached to any development teams. They're not building anything day-to-day. Again, that can work. Just be careful that your centralized architects don't get too far removed from day-to-day goings-on and technology choices. A number of organizations are now taking a much more kind of virtual approach to this. And you'll see this with the Spotify approach, of course, with the whole chapters and guilds things. And I think this tends to work a little bit better, at some levels anyway. So rather than having a dedicated set of people, you're pulling the tech leads and the architects together from the development teams and having them form this virtual central architecture group. And then because they're on the ground and they're seeing the day-to-day runnings and the stuff that's going on, they're in a much better position to help other teams. You still may need some higher level across the top, looking a bit more kind of strategically, but that's that. Fourth thing, autonomy, team autonomy. And one of the questions that people ask me is, well, should we give our teams complete autonomy? And this is something you'll see a lot with organizations who are doing the microservices thing. They're taking advantage of Conway's law. This can and does work. It also doesn't work everywhere. One of the overriding things I see people talking about is this, you build it, you run it. So in these sorts of organizations, a team is given complete autonomy to choose whatever tech they want, whatever deployment platform they want. Everything is their choice. If they build that thing, they look after it. It's completely their responsibility. If the thing breaks at 3 a.m., guess what? They're up at 3 a.m. fixing it. One of the issues with this is that you tend to get lots of stuff happening in organizations. So where 20 years ago we might have had a centralized architecture group that said everybody must use Java, now it seems we're giving teams autonomy and choice. And now one team's using Java, and one's using JavaScript, and one's using Go, and one's using Rust. And that's great for a short time. But then you find that moving people between teams gets hard because you have to upskill people. Hiring people into teams gets hard because there might be a shortage of Rust programmers in your local area or something. And it's just suboptimal in some cases. So what I see a lot of organizations do is they create a platform team or a set of platform teams. And the platform teams provide common libraries, frameworks, APIs, services. And these are not forced choices. So there's a platform team here, and you can use the stuff delivered by the platform team. And if you use the stuff delivered by the platform team, it accelerates your delivery. And this is actually in use in some surprising organizations. So there are a bunch of organizations out there who in public will claim complete autonomy. When you go and talk to these people in private, they're all using the same stack because it's provided by the platform team and it saves them a whole bunch of time. So you get this interesting illusion of choice. It's like you have choice if you want it, but the easier path is over here. So again, just bear that in mind as well. One of the other questions related to autonomy is this, if we gave complete autonomy to all of our teams and have them able to change any line of code in any code base, are we not going to run into a mess? And the answer is actually yes. So I see lots of organizations where anybody can write a commit into any source code repository and stuff breaks. Because ultimately there's no architectural integrity. There are no architectural owners associated with those code bases. So how do you retain architectural integrity while giving teams autonomy? You have a couple of options. You either do like a request for comments thing. So this is becoming more popular in large organizations. So if you have like a whole bunch of code bases and you're doing the Spotify squads thing where a squad can change any line of code across any code base, if they want to make a major change, you have them submit a request for comments, typically globally across the organization. So say these are the changes we think we're going to make. Are there any comments or feedback? Guess what happens? Normally one of two things. Number one, no one replies because they're all too busy. They don't care. It's not their thing. Or number two, everybody replies because everybody has an opinion about some shared thing. So again, you kind of have to treat this with a pinch of salt. One of the other approaches I see teams adopting is they'll explicitly have an architecture owner for a specific code base. So this is almost going back to what we used to do a number of years ago. You make them a gatekeeper. A gatekeeper might be the wrong word to use here, of course, but you want to make sure that any changes that are being made to all of your code bases are done so in a consistent, justified manner. So that's it. Upfront design, documentation, autonomy, and central architecture groups. Thank you very much.